VSEPR theory is a model used to predict 3D molecular geometry based on the number of valence shell electron bond pairs among the atoms in a molecule or ion. The theory states that the electron pairs will arrange themselves around a central atom in a way that minimizes their repulsion. The factors that impact molecular shapes include non-bonding versus bonding pairs, multiple bonds, and the shape's name. Non-bonding pairs are pairs of electrons that are not involved in bonding and are localized on an atom. Bonding pairs are pairs of electrons that are shared between two atoms that form a covalent bond. The number of bonding pairs determines its basic shape. Double and triple bonds are treated as single entities in the VSEPR theory. However, they have a greater repulsive effect than single bonds, and this can affect the shape of the molecule. There are 5 basic molecular shapes that can be predicted using VSEPR theory: linear, trigonoplanar, tetrahedral, trigonal bipyramidal, and octahedral. Shape name is determined by the number of electron pairs and the number of lone pairs around the central atom.
Trigonoplanar geometry. There are 3 bonding atoms and 0 lone pairs. For the shape explanation, there are 3 bonding pairs at the furthest point to create a triangle. Each exists on the same plane. For polarity, it is nonpolar because each atom pulls in an opposite direction. For the hybrid orbital, it is an sp2. Additionally, each angle is 120 degrees. For the trigonal bent geometry, there are 2 bonding atoms and 1 lone pair. For the shape explanation, there are 3 bonds pulling in opposite directions in one plane, but there are only 2 bonding atoms and 1 lone pair, which makes it appear bent. For polarity, it is polar because the 2 atoms pull and don't cancel, creating a dipole. For the hybrid orbital, it is an sp2. Additionally, the 2 bonds between the lone pair and the 2 bonding pairs are greater than 120, and the angle between the 2 bonding pairs is less than 120.
For tetrahedral bonding, there are 4 bonding atoms and 0 non-bonding atoms. It's called a tetrahedral because it has 4 faces, and tetra is the prefix for 4. The hybrid orbital is sp3, and all of the bond angles are 109.5 degrees. For a tetrahedral pyramidal, there are 3 bonding pairs and 1 lone pair. It creates the shape due to bonding electrons forming a pyramid made of 4 planes. For polarity, the lone pair pushes the 3 bonding pairs to create a polar geometry. For example, NH3 is a tetrahedral pyramidal. Its orbital hybridization is sp3, and all of the degree angles are 107 degrees. For the tetrahedral bent geometry, there are 2 bonding pairs and 2 lone pairs. The shape comes from the bonding electrons forming a bent shape with 104.5 degrees between the bonding electrons. For the polarity, the lone pairs on each side push the bonding pairs, creating a pole. For example, H2O has a tetrahedral bent geometry, which makes it appear bent. The orbital hybridization for a tetrahedral bent is sp3.
For the trigonal bipyramidal geometry, there are 5 bonding pairs and 0 non-bonding pairs. The 2 bonding pairs on the vertical plane form pyramids with the 3 bonding pairs on the horizontal plane, causing it to form 2 pyramids with 3 points on each plane, hence the name trigonal bipyramidal. It is nonpolar because there is an equal pull by the 3 horizontal bonding pairs and the 2 top and bottom vertical plane electrons. The hybridization is a sp3d. The angles between the top and side electrons are 90 degrees, and the 3 angles between the 3 horizontal bonding pairs are 120 degrees each. The seesaw geometry has 4 bonding pairs and 1 non-bonding pair. The lone pair on top pushes bonding pairs to form a seesaw-like structure like in the video to the right. This structure is polar as the middle 3 bonds are missing a bond to create an equal pull. An example of this would be SF4. The hybridization is sp3d. The top lone pair forms an angle greater than 90 degrees with the 2 bonding pairs to the sides. The bottom 2 bonding pairs create an angle of greater than 120 degrees with the top lone pair. For the T-shaped geometry, there are 2 bonding pairs and 2 lone pairs. For the shape, the bonding electrons form a T shape with angles of less than 90 degrees. It is polar because the lone pairs push the bonding pairs to form an angle less than 90. The angles between the bonding pairs and the lone pairs, however, are greater than 90, while the bonding pairs all have angles of less than 90 between them. The hybridization is an sp3d. The shape can be explained by the three lone pairs being unable to create their own plane. Since they are equally pushing on the two bonding pairs, they form a straight line, and the angle created between the two bonding pairs is 180 degrees.
For an octahedral, there are 6 bonding pairs and 0 non-bonding pairs. There are 4 bonds on each plane, each equaling 90 degrees. All 6 bonds are 90 degrees apart from each other. It's called an octahedral because if each triangle of bonding pairs was a plane, it would form a shape with 8 sides. An octa means 8. There is no polarity because each bonding pair pulls equally against each other. The orbital hybridization is sp3d2. For an octahedral square pyramidal, there are 5 bonding pairs and 1 non-bonding pair. There are 6 things bonded to the central atom. 5 bonding pairs create 5 angles of 90 degrees, but the lone pair pushes those. This creates 4 angles of 90 degrees with the 4 perpendicular angles. The last bonding pair stays parallel to the lone pair, creating angles less than 90 degrees between the bonding pairs and the single bonding pair, with angles less than 90 degrees between the bonding pairs and the lone pair. It's called a square pyramidal because there is a square shape with a bonding pair sticking out. If we drew out each plane, it would look like a pyramid with a square base. Square pyramidal geometries are polar. For example, BF5 has a central boron atom with 5 fluorine atoms and a lone pair. Since the lone pair pushes the bonding pairs, it becomes polar. The orbital hybridization is sp3d2. For the square planar octahedral, there are 4 bonding pairs and 2 non-bonding pairs. The bonding pairs create 90-degree angles between each other. The lone pairs push equally against the bonding pairs, so each angle is 90 degrees. This also causes it to be nonpolar. Each pair is equally spread. It is called square planar because if we drew a plane, there would only be one plane because lone pairs do not have planes in this model. Since each angle is 90 degrees, it would appear as a planar square. The orbital hybridization is sp3d2.